For the analytical method of vector addition and subtraction, we use some simple geometry and trigonometry instead of using a ruler and protractor as we did for graphical methods. However, the graphical method will still come in handy to visualize the problem by drawing vectors using the head-to-tail method. The analytical method is more accurate than the graphical method, which is limited by the precision of the drawing. For a refresher on the definitions of the sine, cosine, and tangent of an angle, see the figure below. For a right triangle, the sine, cosine, and tangent of theta are defined in terms of the adjacent side, the opposite side, or the hypotenuse. In this figure, x is the adjacent side, y is the opposite side, and h is the hypotenuse. Since by definition, cosine theta is equal to x over h, we can find the length x if we know h and theta by using x is equal to h cosine theta. Similarly, we can find the length of y by using y is equal to h sine theta. These trigonometric relationships are useful for adding vectors. When a vector acts in more than one dimension, it is useful to break it down into its x and y components. For a two-dimensional vector, a component is a piece of a vector that points in either the x or y direction. Every 2D vector can be expressed as a sum of its x and y components. For example, given a vector like A in this figure, we may want to find what two perpendicular vectors ax and ay add to produce it. In this example, ax and ay form a right angle, meaning that the angle between them is 90 degrees. Ax and ay are defined to be the components of A along the x and y axes. The three vectors A, ax, and ay form a right triangle. If the vector A is known, then its magnitude, its length, and its angle theta, its direction, are known. To find ax and ay, its x and y components, we use the following relationships for a right triangle. Ax is equal to a cosine theta, and ay is equal to a sine theta. Where ax is the magnitude of a in the x direction, ay is the magnitude of a in the y direction, and theta is the angle of the resultant with respect to the x-axis as shown. Suppose, for example, that A is the vector representing the total displacement of the person walking in a city. We can use the relationships ax is equal to a cosine theta and ay is equal to a sine theta to determine the magnitude of the horizontal and vertical component vectors in this example. Then A is equal to 10.3 blocks and theta is equal to 29.1 degrees, so that ax is equal to a cosine theta, which is equal to 10.3 blocks multiplied by cosine 29.1, which is equal to 9.0 blocks. This magnitude indicates that the walker has traveled 9 blocks to the east, or in other words, a 9-block eastward displacement. Similarly, ay is equal to a sine theta, and that is equal to 10.3 blocks multiplied by sine of 29.1 degrees. And so this will be equal to 5 blocks, indicating that the walker has traveled 5 blocks to the north, a 5-block northward displacement.